3/4 times the square root of x? Just like yesterday, what's the first thing I need to check for this problem?
Anything with the x?
Anything grouped under the radical with my x. Is there anything there?
No.
No, which means what 3 x values can I use to graph this?
0,
1, and 4. When I plug 0 in for x, I get the square root of 0, which is what? 0. And then what's 3/4 times 0? So 0, 0 will be the first point that I will graph. When I plug 1 in, I get the square root of 1, which is what? 1. What's 3/4 times 1? 3/4. If you are more comfortable, you can write it as the decimal 0.75. It is entirely your choice. This is one of the only times I will allow decimals, yes. And then when I go ahead and plug 4 in, I get 3/4 times the square root of 4, which is 2. I thought I heard it. And then I go ahead and multiply the 2 in. When I multiply the 2 in, it goes to the numerator only. So we get 6/4, which reduces to 3/2, which is 1.5. And then we can graph it. The only difference between this and what we did yesterday is we're going to have some dots that are not at whole number coordinate points. They will be halfway between some numbers. So I go ahead and I graph this. Make that one. I'll make that one half. My first point was 0, 0, so that one goes down first. When I plugged in 1, I got 0.75, which is 3/4. So that's going to be halfway between 1/2 and 1. Just get as close as you can, that's okay. When I plugged in 4, I got 1.5, so I clearly did not make my graph big enough. So I go to 4, I go to 1.5, and then when I have my 3 points, I draw my curve. Again, your graph should start at whatever your first point was and continue indefinitely as it grows. Questions, concerns, or issues with that one? Say that again, hon. No, they're not going to be as pretty, no. No issues with that. Not much different than what we did yesterday. So we are going to go ahead and do another one. This one's going to have a little bit of everything. So this is 1/2 times the square root of x plus 3, and then minus 5. This has a lot going on, so we need to be very careful about the placement when we start plugging stuff in. So the first thing I'm going to suggest is if you like the whole parentheses thing, when I plug it in, you can put parentheses around the radical, and then we just keep everything else the same. The only thing that will change is what we put inside that parentheses. So what's the first thing I need to check for? Say it louder. Confidence. Come on. Anything grouped under the radical with my x. Is there anything there?
Yeah.
Yes. Which means I need to take what's under and set it equal to 0, 1, and 4 to solve for my new x values. I then subtract 3 over on all of these. And I get -3, -2, and 1. So those are the x values that I'm going to be plugging in to graph this. I make my xy table. I put those 3 numbers down. And then we're going to start plugging them in. Is everyone okay on how I got -3, -2, and 1? Anybody confused? Okay, so let's start with -3. I know I have the 1/2, and then I have the parentheses, and then the -5. So the only thing that's going to change is what I put inside the parentheses, and that's going to depend on what my radical comes out to be. So when I take -3 and plug it into my radical, I get -3 plus 3, which is what? 0. And what's the square root of 0?
0.
So I put a 0 in parentheses. And do 1/2 times 0, which is 0, and then minus 5 gives me negative 5. You have to make sure you're doing everything in the correct order for these. Same process for negative 2. When I plug negative 2 into the radical, I get negative 2 plus 3, which is what? 1. What's the square root of 1? 1. So I get 1/2 times 1 minus 5. You're more than welcome to put this in the calculator. And when you do, you should get negative 4.5. And then we do the same thing for 1. So when I plug 1 in, I get 1 plus 3 is 4. What's the square root of 4? 2. And I go ahead and multiply 1/2 and 2 together. What's 1/2 times 2? 1 minus 5, negative 4. So my first point is going to be negative 3, negative 5. My second point is negative 2, negative 4.5. And my third point is 1, negative 4. And I just go ahead and graph that. Starting with negative 3, negative 5, go down or cross to negative 3, go down to negative 5 and put my point. Then I had negative 2, negative 4.5, so it's halfway between negative 4 and negative 5. And then I had 1, negative 4. Once I have my 3 points, I can go ahead and draw my graph as best as possible. So it should look something like this. I'm not an art teacher, so I'm not looking for it to be a perfect curve. I'm also not looking for every single point to be exactly where it needs to be, but it should be as close as you can possibly get. Questions, concerns, or issues so far? No, we're okay. Let's go ahead and do maybe one more. We'll see. This might be the last one. Ariana, what's different about this one than the ones I've previously done? It only has a 9x on the inside, and that 9 is connected to the x by multiplication. It doesn't really change anything. Actually, this makes it pretty easy, because what do I know about 9? It's already a perfect square. So that means anything I multiply by it is still going to come out nicely, because 9 is going to come out nicely. So we actually don't have to change any of our values that we're going to plug in. So if the number being multiplied in is already a perfect square, we change nothing, and we're still just going to use 0, 1, and 4. So let's do that. So when I go ahead and plug 0 in, what happens under the radical? It'd be 9 times 0, which Heath is what?
0.
And the square root of 0 is?
0.
Perfect. So my first point is 0, 0. What happens when I plug 1 in, Madison? You get 9, and what's the square root of 9? 3. So 1, 3 is my second point. And then what happens when I plug 4 in, Carly? I get 36, and what's the square root of 36? 6. So 4, 6 is my third point. I have the 3 points. Now I just need to graph it up. First one was 0, 0. Then I had 1, 3. And then I had 4, 6. And you draw your curve. It is possible when you're graphing these, depending on what the numbers come out to be, to get a graph that looks like this. That's okay too. Just follow where the points are taking you. Okay, that is a perfectly acceptable graph. Okay, so the rest of class is homework time. This homework is still due on Monday, so you have all of class today and you have the weekend. But if you get it finished, please turn it in. That way you don't have to worry about it over the weekend. Sound good? Major questions, concerns, or issues anywhere? Okay. Also, just a reminder, you have one more topic